Molecular orbital theory. Molecular orbital theory talks about molecular orbitals, as valence bond theory was about overlap of atomic orbitals. This theory doesn't talk about overlap of atomic orbitals. It says that atomic orbitals of the combining atoms get intermixed to form, get combined to form molecular orbitals. So, in atoms, you will have atomic orbitals, and in molecule, you will have molecular orbitals. In atoms, atomic orbitals they combine when they form molecule, and in molecule you have molecular orbital. So molecular orbital theory is all about molecular orbital formation and their use in molecule formation. So what are molecular orbitals? When atomic orbitals combine, they combine in two ways. Either they combine in phase or they combine out of phase. They undergo additive overlap or they undergo subtractive overlap. Additive overlap is just as constructive interference and subtractive overlap is just as destructive interference. Why we are talking about interference? It was about wave. Yes, yes, yes. Because quantum mechanics theory says that electrons are in wave form when they are traveling, right? So when atomic orbitals combine in phase, so we say psi a equals to psi a plus psi b. Similarly, when they combine in opposite phase, when they combine in the same phase, then amplitude is summation of psi a plus psi b. When they are in opposite phase, then amplitude of the wave formed is psi a minus psi b. Alright. So this is called additive overlap, this is called subtractive overlap. And now if you want to understand what will be electron density you can calculate by psi a plus psi b whole square, psi a plus psi b whole square or psi a minus psi b whole square, right. Now what is the difference in molecular orbital and atomic orbitals? Atomic orbitals have one nuclei, but molecular orbitals have multiple nuclei of all atoms participating in molecule formation. So atomic orbital is monocentric and molecular orbital is polycentric. Atomic orbitals exist in atoms, molecular orbitals exist in molecules. And the theories like Pauli exclusion principle, Hund's rule, these all are, or above principle for that matter, are applicable on molecular orbital same as on atomic orbitals. Alright. Now you have formation of molecular orbital over here. One is combining to form the number of molecular orbitals formed is equivalent to number of atomic orbitals participating. And atomic orbitals participating in formation of molecular orbital should have energy similar. Not much difference should be there. So 1s combines to give two types of molecular orbitals. One is bonding molecular orbital and another will be anti-bonding. Bonding molecular orbital will be lower energy orbital and anti-bonding molecular orbital will be higher energy orbital. So bonding low energy, anti-bonding molecular orbital high energy. So stable is of course bonding molecular orbital. Alright. So how you will differentiate? We will differentiate as in this we put in a star over here. We put in a star over here. So sigma 1s we put in a star over here. And this is anti-bonding, this is anti-bonding and this is bonding. So if 1s overlap is happening, 1s plus 1s, two types of orbitals are formed. These are molecular orbitals. These are molecular orbitals, right? So two atomic orbitals, these are atomic orbitals. Two atomic orbitals overlap to form molecular orbitals, which are also two in number. Low energy bonding molecular orbital and high energy anti-bonding molecular orbital. More is the number of electrons in bonding molecular orbital, more will be stability. That's it.